Why is the Pipistrel Panthera failing? The endless next year. Every year the Panthera will come to the market next year. The Pipistrel Panthera first showed up at AERO Friedrichshafen in April 2012. It wasn't vaporware. It had a real airframe, retracts, a ballistic recovery system, and a plan to certify a slick 4-seat tourer. The prototype's first flight came on April 4, 2013, after a 54-minute hop, initially with a 210 horsepower Lycoming IO-390, and the early buzz was that Pipistrel had built a 21st century cruiser with sailplane DNA. The sales pitch was simple: near 200 knots true airspeed on modest fuel, carbon structure, and long legs. Independent write-ups and spec sheets through the 2010s generally converged around approximately 194 to 200's true airspeed cruise and approximately 14 to 15 gallons per hour at economy or 75% settings, with manufacturer marketing sometimes quoting even rosier range figures. In other words, Cirrus-class speed with diamond-like efficiency, exactly the combo touring pilots wanted. Pipistrel's story started far from the world of IFR tourers. The company grew up in the Yugoslav era, building ultralights and motor gliders that quietly outperformed much bigger rivals. By the 2000s, Pipistrel had become a serious engineering force in the European light aircraft scene. The Virus and Sinus microlights dominated performance competitions. Later, the Alpha trainer became one of the most efficient primary trainers in Europe, and when most manufacturers were still flirting with diesel, Pipistrel was already flying electric prototypes. By 2010, founder Ivo Boscarol and his team wanted to build an airplane that stepped beyond the microlight category. They envisioned a 4-seat, high-speed touring aircraft that could hold its own against a Cirrus or Bonanza but cost less to run and use less fuel. For a small Slovenian manufacturer, it was an audacious leap. Pipistrel introduced the Panthera at AERO Friedrichshafen in April 2012. On paper, its specifications were compelling. A 4-seat, all-carbon composite airframe powered by a 210 horsepower Lycoming IO-390, capable of cruising around 190 to 200 knots true airspeed while burning 10 to 12 gallons per hour at economy power, or about 14 to 15 gallons per hour at 75%. It offered a range of roughly 1,000 nautical miles with reserves, a service ceiling of 25,000 feet, and the option to run on aviation gasoline or motor gasoline. A ballistic recovery parachute was integrated into the structure from the start. The combination promised an aircraft that could deliver high cruise speeds, long legs, and low operating costs in a modern, efficient design. But the first domino to fall was the engine and fuel plan. From the start, Pipistrel wanted the Panthera to be MoGas compatible. The IO-390 seemed perfect, light, proven, and small enough to keep the center of gravity in check. Early tests showed great numbers, but when the certification process dug deeper, detonation margins on automotive fuel didn't meet the EASA standards across the full power envelope and temperature range. Lycoming was reluctant to certify the IO-390 for MoGas operation at those compression ratios. Without a certified MoGas engine, Pipistrel faced a problem: either redesign the fuel system for avgas only, losing the marketing edge, or find another power plant. They chose the second path. And that forced a pivot in 2014 to the 6-cylinder Lycoming IO-540, a heavier engine that changed the airplane's math. Plus 41 kilograms, approximately 90 pounds, engine weight increase, and a corresponding maximum takeoff weight increase of approximately 95 kilograms to claw back useful load. That single decision rippled through every part of the program. The heavier engine up front forced a complete review of weight imbalance and structural margins. Engineers had to recheck center of gravity limits, pitch inertia, and engine mount load paths, then rerun flutter and structural analyses before returning to envelope expansion flights. A heavier nose shifts aeroelastic behavior and handling characteristics, all of which must be reproven under certification standards. Even though Pipistrel had originally sized the cowling for a 6-cylinder option, The IO-540 installation still required validation of cooling airflow and baffle efficiency across the temperature and altitude envelope, a fresh stack of ground runs and flight tests. Pipistrel publicly noted that the new engine improved short-field and high-density altitude takeoff performance and even kept the door open for motor gasoline operation. But those gains came at the cost of extra test work and paperwork. Finally, all performance cards had to be rewritten. With the new engine and expanded fuel options, up to about 91 U.S. gallons, around 83 usable, the aircraft's maximum takeoff weight rose to roughly 3,000 pounds, 1,360 kilograms. That change meant redemonstrating takeoff distance, climb rates, stall speeds, and landing performance, while avionics and interiors evolved in parallel. With prototypes flying Garmin G3X Touch and Garmin G1000NXi targeted for the certified variant. Certification got different in the middle of the program. Just as the Panthera was closing in on certification, the EASA changed the game. Around 2017, the entire Certification Specification 23 rulebook was rewritten into a new performance-based system. It was meant to make approvals more flexible, but for Pipistrel, it meant starting over in key areas: new paperwork, new interpretations, and new ways of proving things they'd already tested. The goalposts moved, and what should have been a final stretch toward approval turned into another round of adjustments and rework, costing more time and momentum. By 2018 to 2019, prototype testing was mature, with prototypes primarily flying on Garmin G3X Touch. Garmin G1000NXi was targeted for the certified variant later, and documentation for certification was underway. Flight trials confirmed the airplane's real-world performance: approximately 194 knots true airspeed at 75% power, 14.8 gallons per hour, and high 180s knots true airspeed at economy settings. Then came 2022. Textron, owner of Cessna, Beechcraft, and Bell, announced the acquisition of Pipistrel, folding it under a new unit called Textron eAviation. The public message was clear: Textron wanted Pipistrel's electric and hybrid expertise to accelerate sustainable aviation projects. The Panthera was mentioned, but only in passing. Initially, optimism remained. Textron's size and certification experience could finally push the project over the finish line. The new owners even declared 2024 as the target for EASA certification, followed by FAA validation. It seemed like the long-awaited next year might actually arrive. When Textron acquired Pipistrel in April 2022, it wasn't because the American conglomerate suddenly wanted to sell composite piston singles. Textron already owned Cessna and Beechcraft with a full catalog of piston, turboprop, and jet aircraft. What Pipistrel brought to the table was something Textron didn't have at all: a certified electric airplane and a credible engineering lead in alternative propulsion. It's safe to think that Textron didn't need the Panthera. At the time, Pipistrel's Velis Electro was the only aircraft in the world with a type certificate for an electric powertrain. That's what made it strategically valuable. Textron wasn't buying Pipistrel for the Panthera. It was buying the future of electrification. The acquisition created a new division called Textron eAviation, a clean sheet unit tasked with developing electric and hybrid electric aircraft. Inside Textron, the Panthera was reclassified as a certification program in progress, no longer an independent flagship. It now had to compete for funding with experimental projects that aligned better with Textron's public sustainability goals. For a small team, used to fast, iterative decision-making, the transition was massive. Pipistrel had gone from a family-run innovator to a node in a $14 billion corporation. The results showed fast. The 2024 certification target announced shortly after the acquisition came and went quietly. By early 2025, Textron stopped giving public timelines altogether, citing ongoing testing and validation. For pilots watching from the outside, it looked simple. The airplane still flew beautifully, but its momentum had been replaced by bureaucracy. The Panthera no longer looks like a hero project. Where a small Slovenian team once made decisions in hours, Those decisions now flowed through layers of bureaucracy. Every design consideration now need to move through a chain that included not just engineers, but bureaucrats in Wichita. That's how big companies keep things consistent, and how small projects lose oxygen. Meanwhile, the eAviation division's resources were being pulled toward electric and hybrid platforms that executives could point to as the future. At investor days and sustainability conferences, slides showed Velis Electro fleets training green pilots and hybrid Panthera demonstrators as proof of concept for eco-propulsion. The piston Panthera, the one real pilots could actually buy, didn't fit that narrative. In early 2025, insiders confirmed that 4 credit EASA flight tests were still running and structural tests were in progress, signs the airplane wasn't dead. But there was no published certification schedule, no production ramp plan, and no marketing effort. Textron isn't new to this. Its aviation portfolio is built on discipline and pragmatism, not sentiment. Across its aviation brands, Cessna, Beechcraft, Hawker, Bell, and now Pipistrel, Textron has shown the same mindset for decades. If the numbers don't justify the program, it doesn't matter how elegant, how fast, or how much pilots love it. It goes. Take the Cessna Citation Columbus. Launched in 2008, it was meant to be Cessna's first true long-range business jet. 4,000 nautical miles, large cabin comfort. The company shot at Gulfstream and Bombardier. But when the 2009 recession hit, orders dried up. Halfway through development, Textron cut its losses. Then came the Skycatcher, a low-cost light sport trainer with a noble idea, to make flying affordable again. The execution wasn't. By 2014, rising manufacturing costs, an overhyped price target, and limited global demand sank it. Textron ended the line, sold off unsold units for parts, and moved on. It's the same story with the Cessna TTX, the composite high-speed evolution of the Columbia 400 that Cessna inherited in 2007. It was faster than a Cirrus, better in climb, and handled beautifully. It just didn't have a parachute, and that was a problem. By 2018, with fewer than 300 built, Textron quietly shut the line down. The airplane wasn't bad. The business case was. The Scorpion light attack jet showed how far Textron would go to test a concept, and how quickly it would walk away. Built with its own money through Textron Airland, the Scorpion was a low-cost strike aircraft aimed at export markets and budget-conscious air forces. It flew, it performed, and it wowed observers. But when customers didn't materialize, Textron simply stopped writing checks. The prototype still exists. The program doesn't. Even successful designs eventually get retired when they stop fitting the model lineup. The Citation Mustang, once Cessna's best-selling very light jet, was dropped in 2017, replaced by the Citation M2, which shared more parts with the existing CJ family. The Citation X Plus, fastest civilian jet in the world, ended in 2018. Its niche market didn't justify production once the Longitude arrived. The Sovereign Plus, phased out in 2021, made room for newer, more profitable models. And the Hemisphere, a bold attempt at a large cabin Citation, was frozen in 2018 after Safran's Silvercrest engines failed to deliver. Add to that the Hawker 4000 and Premier IA, both quietly left in the grave after Textron bought Beechcraft out of bankruptcy in 2014. Textron chose to focus on King Airs and Barons instead of reviving expensive jets with limited fleets. If a project doesn't meet cost, volume, or strategic goals, it gets paused, rebranded, or scrapped, even if it's brilliant. And if something does fit, like the Sky Courier, Denali, or Latitude and Longitude, Textron will fund it for years until it delivers. That's why the Panthera's limbo isn't surprising. From a pilot's perspective, the airplane clearly flies, clearly works, and fills a niche that modern general aviation badly needs. But from Textron's point of view, Panthera is a beautiful low-volume piston that would soak up expensive certification and support for modest sales, while pulling talent and cash from Denali, Sky Courier, Citations, and electric or hybrid programs that drive their revenue. It's not like the Panthera will outsell a Cirrus or a 182. A plane Textron will bet their hearts on will be one that outsells everything in its class. If Pipistrel had stayed independent, would the Panthera be flying with type certificates by now? Quite possibly, though not without trade-offs. As a standalone company, Pipistrel had speed, focus, and passion, but limited funding. Certification under EASA is expensive. The company's smaller scale meant progress was steady but slow. One engineering setback or funding gap could stall the entire schedule. Yet independence also meant agility. Decisions were made by engineers, not executives. When early prototypes flew, Pipistrel could pivot quickly between test cards and modifications. Had the company continued on that trajectory, especially after 2018 when most structural work was complete, it's reasonable to think a limited initial EASA approval could have arrived around 2020 to 2021, with later upgrades following. Would Panthera have given the SR-22 and SR-22T a real fight? Short answer, below the teens, yes. On speed per gallon, the Panthera looks very strong against a normally aspirated SR-22. Up high, no. A turbo SR-22T holds power and stretches its legs where the Panthera IO-540 non-turbo starts running out of upper altitude performance. In real-world cruise, the numbers tell a clear story when compared at similar power and altitude bands. The Panthera's IO-540 typically delivers about 194 knots true airspeed at 14.8 gallons per hour at 75% power, according to both manufacturer data and AOPA testing. The Cirrus SR-22's IO-550 sits lower on the curve. At 65% power and 8,000 feet, it runs around 171 knots true airspeed on 15.4 gallons per hour. Push it to 75% power, and you'll see about 180 knots true airspeed on 17.8 gallons per hour. In the same 8 to 12,000 foot bracket, the Panthera cruises faster on less fuel, showing roughly the same speed as a high-power SR-22, while burning 2 to 3 gallons per hour less. But the SR-22T with the TSIO 550K is a different animal. At 75% lean of peak, fuel flow sits near 16.4 gallons per hour, but the speed depends entirely on altitude. Down low, it's not much quicker than the Panthera, yet in the high teens to low 20s, where the turbo can hold full manifold pressure, it stretches out to the advertised 210 to 213 knots true airspeed. That's achievable, but only up high, with oxygen, good engine management, and careful temperature control. But judging based on how most pilots actually fly, at 8 to 12,000 feet, the Panthera is approximately 194 knots true airspeed on approximately 14 to 15 gallons per hour is outstanding efficiency. The SR-22 showing 171 to 180 knots true airspeed on 15 to 18 gallons per hour burns more fuel for less speed. But climb into the flight levels 18 to 20,000 feet and the equation reverses. The SR-22T's turbo lets it keep power and cruise comfortably above 200 knots true airspeed, leaving the non-turbo Panthera behind once density altitude stacks the deck. Speaking of range and what you can actually load, when you look past brochure range and compare how these airplanes are actually flown, the picture becomes much clearer. The SR-22T carries a useful load of about 1,238 pounds and 92 gallons of usable fuel. Cirrus quotes a maximum range of roughly 1,021 nautical miles at 55% power, but that's the long-range, low-power scenario, with 3 hours and 45 minutes of fuel on board, more typical for a cross-country flight. Cirrus's own data shows a cabin payload around 892 pounds, enough for 3 larger adults in bags or 4 lighter adults. The SR-22, normally aspirated, is a little lighter on its feet. The 2022 specifications list a useful load near 1,328 pounds and a cabin payload of about 963 pounds on the same 3 hours and 45 minutes fuel assumption. The absence of the turbo system and lower fuel flow give it slightly better short-trip payload flexibility than its turbo sibling. The Pipistrel Panthera, according to AOPA testing, carries about 55.4 gallons of usable fuel in its standard configuration, with a payload of roughly 770 pounds with full tanks. That puts the useful load a bit over 1,100 pounds, varying slightly by build and interior fit. With full standard fuel, around 332 pounds of fuel weight, you're left with 770 pounds for occupants and baggage. In real terms, that's two 200-pound adults and 2 kids with bags, or 3 190-pound adults with light baggage, all within comfortable margins. Some experimental examples have optional long-range tanks, but the published AOPA figures reflect the certified baseline. Here is where each one shines. At higher altitudes, the SR-22T dominates. The turbocharger keeps power into the flight levels, giving strong climb and cruise performance well above 200 knots true airspeed in the high teens and low 20s. Those numbers require proper oxygen use, careful mixture management, and temperature discipline, but the performance is there when managed correctly. At low to mid altitudes below 12,000 feet, the Panthera is the standout. Its approximately 194 knots true airspeed on 14 to 15 gallons per hour makes regional trips between 400 and 700 nautical miles fast and fuel efficient, without oxygen, turbo maintenance, or the heat management that comes with the TSIO-540. When it comes to cabin comfort and ecosystem, the advantage still leans towards Cirrus. The Cirrus airframe parachute system legacy, global service network, established training programs, and strong resale values make ownership straightforward. For many buyers, that ecosystem outweighs a few gallons per hour either way. But behind the marketing numbers, the SR-22T's 213 knots true airspeed claim lives in the high teens and low 20s at best economy power settings, in clean air and lightweight, with precise engine management. In everyday 8 to 12,000 foot cruise, most owners see upper 180s knots true airspeed on mid-teens gallons per hour when flying lean of peak. The Panthera's 200 knots true airspeed headline figure also softens a little in practice. AOPA testing reports approximately 194 knots true airspeed at 75% power on 14.8 gallons per hour, with most pilots seeing high 180s to low 190s knots true airspeed depending on conditions. Its 55.4-gallon standard fuel makes it ideal for regional touring, but it's not a long-range tanker. In short, at oxygen-free altitudes, the Panthera outpaces the normally aspirated SR-22 and nearly matches the SR-22T's speed on less fuel. But once the turbo climbs into its element, the SR-22T regains the lead, just at a much higher cost per mile and complexity per hour. Leaving a comment and liking the video helps me a lot. Don't forget to subscribe and ring that notification bell.